So welcome everybody to Wrong Answers Only. Um, so for this instruction routine, well, first I wanted to shout out Zuzka Blasi, who is a member of the Adult Numeracy Network. She's an adult education teacher in Massachusetts, and she created this instruction routine. Thank you to Zuzka. So here's the way this routine will work. I'm going to present you with a question, a mathematical question, and your job is to come up with an incorrect answer. And so what we'll do is when I share the question, we'll don't shout at anything. We'll give everybody some time to settle in. I'll give you about maybe 45 seconds, or longer if required. But your job is to come up with an incorrect answer. You can come up with more than one if you'd like. But then after that, we'll come together and we'll share both our incorrect answers and also our reasoning for how we know that that answer is incorrect. Okay. Any questions about what we're going to do? Okay. I will say we're going to try to do two. So we'll see how it goes, but just to give you, a wider sense. But I'm excited. For how many? Wait, give me a thumbs up if this is your first time ever doing wrong answers only. Okay, cool. Excellent. So I'm excited. And here we go. So your first question. So again, I'll give you some time to think about it and then we'll start sharing. But wrong answers only. What is 72% of 12? That was my best 1980s game show voice. What is 72% of 12? So take a little time. Maybe give me a thumbs up once you have something. Okay. Yeah, and you can just flash it because I'm just watching so I can see. Okay. Does everybody have at least one incorrect answer? Okay. So let's start sharing. So I'm gonna try to take notes as we go. Can you see as I type? Can you see? Yeah, okay, good. Okay, so I'll start just by reading what Amanda wrote in the chat. Amanda said 6 because that is 50%, 12. Cool. Thank you, Amanda, for getting us started. Ooh, Cynthia says 12 because it's 100%. Oops. Mary says 3. That's part of 12. Mary, can you say a little bit, tell us more about what you're thinking when you say 3, that's part of 12.
Well, I feel like sometimes with students, the math facts will just kind of pop into their heads, and three's a factor of 12, and I feel like that might just pop out. And I would guide them to thinking about a benchmark fraction at that point.
Well, do you know, so you're kind of thinking from the perspective of a student. Do you know that 3 is not 72% of 12? Like you, Mary Carlson?
Yes,
So
well
how do
aware.
you, so how do you, well, no, but that was just leading to my next question, which is how do you know? Because there's lots of ways that you
How
might
do I
know.
how do I know? Because I know that 72 is almost 75 and 75 is three quarters of 12. I'm trying to follow the student's thought process. They might come up with some of that and think, ooh, 3 and 4, and they go together with 12, and maybe I should say three.
So you're saying I know that 72% is almost 75, and that would be three quarters of 12, and you know that 3 is not three quarters of 12. Is that, I
Right,
just want to make sure I got,
right.
okay. Awesome. Thank you. Other folks? I am going to be sneaky. Does this work? Ooh, it does. I just cut and paste from the chat. So Karen said 1.2 because that is 10% of 12. Karen, can you talk us through your thinking a little bit?
Um, well, I know that you just moved the decimal over once for 10%.
Okay.
Wait, did I do that right?
I would say it's my understanding that 1.2 is 10% of 12. I think that's a true statement, what you said. Um, Lori, yours sounds a little bit like Mary's, but also a little different. So can you talk a little bit to how you were thinking about it?
I was thinking about the three, and then somebody mentioned three, so then I decided to make it larger than the 72% by increasing it three times because since three was 25%, then three of those would be 75%, which is larger than 72%, which is nine.
hmm Okay, very cool. So similar to Mary's, but
Mm-hmm.
almost yours is maybe a little bit more visual. I don't know if it was visual for you, but the way you just
Mm-hmm.
described it helped made me picture it in my head because you were kind of I was picturing sets. Like picture this
Yeah.
25 three times. Cool.
Mm-hmm.
Michelle, let me see. Ooh, nice. Um, Michelle, can you tell us about 20 because that's more than 12.
Yeah, so I was just trying to come up with something that's, you know, more than 12 because we know 72%, 72% is less than 100%. Um, so, something more than 100% is clearly not the right answer.
Mm-hmm. Cool. So that kind of goes hand in hand with what Cynthia said. Like, or it
Yeah.
connects it kind of builds, yeah. Ooh, and let me ooh. Aaron, yeah, there it is. Can you talk a little bit about your what you have there?
Yeah, I mean it's actually kind of my thinking was inspired by some students that I had opportunity to see doing the routine that they
Hmm.
consider are there units involved? And in this question, there are no units involved. So, I mean, I made a guess at a number that I thought was actually kind of close to 72% of 12, but it would be the wrong answer anyway because the question isn't about inches.
At least not as it's
Not as it's given to us here.
not as it's given.
Yeah.
Very cool. Okay. Cynthia wanted to add one more, and I created some space. Cynthia, you want to tell us what you were thinking there?
It was the second one I thought after I did the 100. Like I went
Mm-hmm.
to both extremes, like 12 and 1. And 1 because it's too small of a part. Because the percentage is part of the whole is 12, so 1 would be way too small to be 72%. Like so
Mm-hmm.
it's a too small of a part.
So looking at these, so in all of this incorrect answers, there's so much information, there's so many things different ideas of things that we know. One of the things that I'm noticing is I'm just trying to look at this. So anything more than 12, like Michelle gave us the number 20, but then she also, when she was explaining her thinking, she said anything more than 12 is going to be more than 100%. And Cynthia said 12 is 100%. Like, so that's one cutoff. Um, Six, and I forgive me, I'm sorry, who was it that started? It was Amanda. So Amanda started us off by saying six because that's 50% of 12. Um, so 72% is more. So it's between already, I know it's somewhere between 6 and 12. We have some nine. Nine came in because that's three sets. So it's interesting to me, kind of like the range of all the numbers, kind of even in the incorrect answers, even though we're not trying to answer the question, how much information how many ways to think about how to answer this question are here, right? There's also this idea of benchmark fractions. Mary was the first one to mention it, and then Lori was talking about the 25s, and 75 came up. Cool. So this was a very cool. That's it. That's the routine. So guessing because you're a bunch of thoughtful teachers that there's some teaching ideas that are coming, but I'm going to encourage you and ask you to kind of hold off, stay in the like I'm a learner and I'm looking for wrong answers, because we're going to do. I think we definitely have time to do one more, and I think when the point that Aaron was making about routines, it's kind of hard to convey that when you only see it once because the idea of it is what it's like to see over. So we're going to just jump right in to the same. So I will turn it over to Aaron. They'll facilitate, but I'll type for you. Okay.
Thanks.
Yeah.
Okay, so here is our next prompt, our next question. So the question is, what is the value of X, or what does X stand for? And as we did before, let's take a few seconds to think about what might be a good wrong answer to this, and then we'll start collecting. You can, if you've got one, give a thumbs up. I see we've got one in the chat already, or some popping in the chat. Don't look at the chat if you're still thinking of your own. Okay, I think we can jump to discussion because we've got a lot showing up in the chat here. So we have to start, so many things in the chat that I lost track. Karen said X equals 18 because one thing that's interesting about you putting this in the chat is that I'm not sure. Can I ask you to read it out loud? Because there are different ways we could read the notation that you've put there.
Okay, so I said X equals 18 because 18/20ths is more than 1/2 and 3/15ths is less than 1/2. So they're
Okay.
not the same.
Okay, so thinking of these as equivalent fractions, 18/20ths is more than a half, and then the 3/15ths is less. That would make them not the same. Okay. Mary, you said 60, and you've given an explanation cross multiplication. Can you say a little bit more?
Yeah, I know that students, that's one of the tools in their toolboxes, the cross multiplication strategy. And I could see them looking at this and seeing, okay, well, we've got a missing value. Maybe if I just multiply 20 by 3, that's the missing value.
Okay. So again, like Mark asked in the last one, you personally, how do you know that 60 is an incorrect answer here?
I mean, I'd be looking at the proportionality there, right?
Mhm.
I know that 3 is 1/5 of 15, so that would be how I would think about it. And I think I would think about it visually a little bit. I mean, I'm trying to balance the two sides of the scale. So right away, 60 over 20 is 3. So I know that's way too much. But I think if you don't have those visual models and you're not like comfortable with the idea of equivalent fractions, you might just think, oh, well, that's a reasonable number because again, because 3, I'm cross multiplying, and so maybe that's it.
So another thing you could also say if you're thinking about the strategy of cross multiplication and you want to bring it into the context of wrong answers only, you could say, I know that the answer is not 60 because when I'm cross multiplying, the first step is to multiply 3 times 20, but I'm not finished with it when I've done that. So 60 is not the right answer.
I found that when teaching fractions, one of the big hurdles is that there can be many steps. You might have to find a common denominator, you might have to reduce, and they don't really know when to stop or when to keep going.
Right. So the thing is though here, like we're thinking about it as learners, how like how can we do it wrong? That is our goal here is to do it wrong, and then to talk about how we know that it's wrong. So let's look at some other ones. So Amanda says 8 because it doesn't preserve the proportion. So I would like to hear a little bit more about that as well, Amanda. I know you're off mic, so if you have anything to add to that in the chat, that would be great. But I'll go on to Cynthia said 10 because it would be 1/2. So that means that the fraction on the right would be equivalent to 1/2, and the fraction on the left is not. Okay. Michelle says 1 because 1/20th is smaller than 1/5. Very interesting. You want to say any more about that, Michelle?
Yeah, sure. So I think it's related to the other two where the proportion isn't kept the same. If I think of like a pie and I cut it into fifths, I mean, I kind of jumped to 3/15 is 1/5. But the 1/20th is a much smaller piece. I guess I could see, students just maybe trying to, come up with a smaller fraction or just come up with something that they think seems like a small fraction. So this would be like if they didn't even think of like the cross multiplication.
Mm-hmm. Yeah, so seeing these as fractions and just asking, can I come up with something that's smaller that definitely doesn't match? So we've got Lori said any number above 20 because that would be improper. Okay. And Cynthia says this would be her favorite no on this. Do you want to say what your favorite no is, Cynthia?
My favorite no is an instructional routine that I like. But that's what I was looking for. It's like that would have been the one that I would have said, but Lori said it. But when I thought about why I liked it the most, it was because of the concept of going at that this is greater than the whole. And what does it take to make it greater than the whole? And then recognizing that the other one is less than the whole. So that one's my favorite no.
Nice. Amanda, thank you for giving us some more information about your 8 previously. 15 minus 3 is 12, and 20 minus 12 is 8. So sort of applying the same mathematical operation to both sides, but that's not a subtraction operation is not the operation we use when we're thinking about equivalent fractions or proportions. So thanks for calling that out. Mark, you have 19 because 19/20 is almost 1 and 3/15 is not almost 1. Do you want to say any more about that? You're muted.
I think you summarized it or you restated it perfectly. But yeah, just I mean, I maybe just to put it in the context of the last one, like I like the idea. I did it because someone talked about 100% in the last. I was just thinking about like that end of the spectrum. So like it's making it close to 1 was kind of my goal. Yeah.
Okay. I think I'm gonna stop our recording because we're gonna get ready to go into our teacher analysis.